Okay, the Schmitt trigger on page 245, Even Start Technology. There's its electronic symbol here in the middle. Okay, so it looks like a logic gate. And here we have three signals that we'll talk about now in a minute. And three output signals that you would get. And I suppose its number one job is to stabilize noise on electrical signals, especially from analog sensors. Okay, so yeah, if you can imagine this first graph here is very up and down. It's analog. You know, it could be representation of heat or light or something like that. And what we have down below here is a comparator signal representing the same data. Okay, so it's been converted to digital here. Okay, but that's from a comparator there. Okay, and down below here we have the Schmitt signal. Okay, taken from our analog signal, which is, you know, it's smoother, it's more stable. It'll give you a cleaner, crisp output as opposed to our analog one here. Okay. Yeah, so the Schmitt trigger itself can be integrated into microchips, okay, onto the inputs, whereby there could be fluctuations in voltage. Yeah, so that'll help there. And it can also be used to help debounce, okay, or eliminate bouncing. Okay, so you might see this in your exam, this term, debouncing. Just draw that in there, just underline it. So you might see debouncing written in the exam. All right. Now to analog debounce, so that would be to build a circuit like this into a chip, or physically build one. Would be whereby this is a switch. Now, debouncing is a term used when you make contact between two metal surfaces in a circuit, like a switch. So when a switch makes contact, sometimes it can bounce, so you're not getting a clean, crisp signal from it. Might be a little bit jumpy, literally bouncing. Okay, so you know, when it runs past, or well, the analog circuit here, you know, has it running past a diode here and a capacitor here to possibly slow it down, and then our Schmitt trigger gives us a final debounced circuit here. Okay, so it's after eliminating electrical noise there. Okay, I suppose you could say the noise being the bouncing of the switch. Okay, now that's the analog way to debounce using a Schmitt trigger. We can also debounce. Okay, we can also debounce another way, and that's using software. Okay, whereby the computer program has to change a fast changing sequence of ones and zeros. So that would be the noise there. We've got a lot of ones and a lot of zeros, when in fact we should either have just a one or a zero.